Alright, so hopefully you took some time. How'd you do on the guided practice, do you think?
I'm feeling all right, but let's see. Let's test it out to see if I got everything right.
Alright, so we want to know how many grams of aluminum do you need to make 2.5 moles of copper? And you already have this balanced equation in your notes. But, just to write it down again, we know that 2Al
2Al
plus 3 copper nitrates,
NO3.
and that's copper 2 nitrate, by the way, gives us 3 coppers plus 2 aluminum nitrates. All right. So.
All right. Given is 2.5 moles of copper.
Okay, and we want
grams of aluminum.
Okay, so now.
Okay, so we've got 2.5 moles of copper, which we also want down here on the bottom. And we want, let's see, we're in moles.
We're in moles, which means we don't have to deal with our molar mass right now. It's just like the first problems we started out with.
So then we can do moles of aluminum.
And where are we going to get those moles?
All right, we want to look at our equation. So there's aluminum, there's copper. All right, I'm going to keep those numbers with the units. Okay, so moles of copper went away, but I noticed that I'm not done because I want grams of aluminum. All right, so I need to keep going.
So we've used the 1 unit conversion we know we can use. We know we can use our mole ratio from our balanced equation. What's our only other option?
The only other one that we have left to use is molar mass.
Right, and we know that molar mass is the mass of how many moles?
1 mole.
1 mole, and where, especially if it's nice, like just being aluminum, where do we look?
I looked at the periodic table.
And we find that our molar mass for aluminum is 26.98 grams.
26.98 grams.
Right.
Okay.
And so now, what are our units that are left?
All right. Cancel out moles of copper, cancel out moles of aluminum. So the only thing that's left is grams of aluminum.
And that's what I wanted.
Okay.
So now we're going to multiply everything on top.
And then divide. So 2.5 times 2 times 26.98. Divide that by 3.
So we're going to plug all of that into our calculator, and we find out that if we're trying to make 2.5 moles of copper, it is going to take us 44.97 grams of aluminum.
I got a little excited and I was copying down my answer for the wrong one. Okay.
All right. And so again, we haven't done any new math. We've just taken the parts we've already taught you, the parts you're already comfortable with, and added and just put it in a slightly different order. We started in moles, so we used our mole ratio first, and then we used our molar mass. All right, now we've got one more problem that we're going to work on that you should have tried on your own that we'll work through together before we set you loose. So, again, we need to make sure we've got our balanced equation. You've got it on your paper, but in case we're missing things, we're going to write out that we've got lead 2 nitrate reacting with 2 sodium iodide to give us lead iodide, this is lead 2 still, plus 2 sodium nitrates. Alright.
Okay.
So, again, we're still going to read through our problem. We're still going to figure out what we're given. We're still going to figure out what we want. So, we've got, and again, you already had on your paper, we forgot to put in the slide, that what we're given in this problem is
25 grams of lead 2 nitrate, which was the PB. Alright, we know what that is now. NO3 2.
Alright.
And we want grams of Na I.
So this looks a little different than what we've done, because we've done mass to moles, we've done moles to mass, and this time we've got mass to mass. But again, the math hasn't changed. We're not doing anything new. There's still only 2 unit conversions we can use. We can use mole ratios. We can use molar mass. So let's set this up.
All right. So I'm starting with what I was given, and so I was given 25 grams of PbNO3 2.
And I know if I've got grams of PbNO3 on top, I need
grams of PbNO3 2 on the bottom.
And if I'm in mass, I know I have to get to
get into moles.
And the only thing we can use for that is our molar mass.
All right.
All right, so even if you're not trying the guided practice on your own, try to come up with molar mass of lead nitrate before we write it down. Lead nitrate should work out to 331.22 grams. If you did not get that, ask your teacher where you went wrong. I'm pretty sure I know, but ask anyway. All right, so now our grams of lead nitrate,
those are gone.
Those will cancel out. We're in moles of lead nitrate. So once we're in moles of one substance,
now we can use the other unit factor, which is the mole ratio. All right, so we've got mole of PbNO3 2.
Okay.
And I want sodium iodide, so I'm going to do moles of sodium iodide. And we need to look at our balanced equation.
So we don't have anything written in front of lead nitrate. So if nothing's written, it's like X, it's got to be 1. And then we look at sodium iodide.
There's a 2 in front of that one.
Alright, so our moles of lead nitrate cancel out.
Woohoo!
And that gets us to...
Alright, so now we're at moles of iodide.
Now we're at moles
sodium
of iodide.
But we want grams.
We want grams. So we've already used our mole ratio, and guys, no matter what's going on in your problem, you're never going to use mole ratio more than once. You may, however, need more than 1 molar mass, and this is one of those times.
Alright, so I'm going to... Let's see. I'm just going to continue it right there so we can see everything together. So 2 moles of sodium iodide. That means on the bottom needs to be mole of sodium iodide. And on top,
we're going to need mass.
We want mass, which is grams of sodium iodide.
And if we're doing moles to mass, we're using 1.
The molar mass.
And it's always the mass of 1 mole. And then try again to find your molar mass of sodium iodide before you write it down. Molar mass of sodium iodide should work out to be 149.89 grams.
Okay, so let's see the...
So the moral of this story is make sure you've got plenty of room to show all your work. But when we plug it into our calculator, we're going to have 25...
25
times 1
times 1
times 2 times 149.89, and then we're going to divide by
31.22.
All right.
Okay.
So we plug all that in our calculator. We give ourselves a little bit more space, and we should get that we need 22.63 grams
of sodium iodide.
This is as complicated as these problems can get. So the farthest you can go is mass of one thing to mass of something else. But again, it's not new math. It's not anything more complicated. You just have to keep track of what you're doing. So we went from mass to moles using molar mass. And then we went from moles to moles using your mole ratio. And then we got to our new mass using a different molar mass again. And again, it's not anything new. We've done this before. It's just dimensional analysis. Just keep plugging along, using all your units. And remember, we've got to use our molar mass if we're converting between moles and grams, or grams and moles. It doesn't matter which way. Same thing both times, and that's always the mass of 1 mole. You're going to use your mole ratios if you're converting between different substances. And remember, those come from your coefficients and your balanced equation. And you're only ever going to use that one once, no matter what you're doing. And it doesn't matter whether your substances are reactants or products or both on one side or both on the other. Your math is always going to be exactly the same. And no matter what you do, if you are not in moles, you are going to need to get there. So keep going through your moles. Believe us. Do it. Accept it. Move on. All right. So now that is all of these stoichiometry calculations we can do. Let's go try some on your own. If you still need help, please do ask your teacher. We are there for you.